Hello, welcome to a brief introduction to how to use graphs. In this presentation, we'll talk about why we use graphs in science and how you choose the type of graph that you're going to use. So here we go. So using graphs in science. The reason for graphs, there are lots of reasons and you may have your own. The ones I came up with, obviously, graphs help us explain our data in picture form. Many people find it a little bit easier to read stuff when it's a picture, and so this is a good way to kind of put our data together in a way that's easily digestible by our audience. Secondly, sometimes graphs present a lot of data in a small summary form. If you do a real scientific experiment, you may have thousands of points of data, and putting that all together in a graph or a table can be really helpful. And graphs do a really good job of explaining some of the relationships between one group and another. There are different types of graphs. The ones that we're going to go over today are pie graphs or pie charts, line graphs, bar or column graphs, and Venn diagrams. We'll talk about each of these, give some examples, and explain when you use each. So pie graphs, great tools. Pie graphs are good for showing relative frequencies. That language might be a little challenging for you, so here's an easier way of thinking of it. You use a pie chart or a pie graph when all of your categories add up to 100%. Maybe you did a survey, you said, what's your favorite Star Wars movie? And you got a group of people to respond. Well, they have to pick one of those Star Wars movies. So everybody's going to pick one. It will add up to 100%, and you'll have, 60% say Empire Strikes Back, and then so on. And so pie graphs are a great way when you have a whole 100%, good for surveys, good for information, where it all adds up to 100%. Everybody has to have chosen a category, or everybody has to have fit into a category. So pie graphs, of course, get their name from pie. They look like little pieces of pie eaten, and this is about as simple a pie graph as you can get. There's pie you've eaten and pie you have not eaten. So you'll see it has a nice legend in the corner. Legends are always good, and it lets the audience know what we're looking at. Got a couple other humorous graphs here. Good old pie graph. Supposedly Pac-Man, the original Pac-Man, was inspired by pie. So here it is. The percent that resembles Pac-Man is yellow, and the percent that doesn't is in purple. More graphs. Again, they show relative frequencies. This one's kind of fun. Talks about how cats most of the time find the package more interesting than the toy itself. Again, adds up to 100%, the two different options for the cat. Colon use. So here's another pie chart. What do we use colons for? This graph is, again, trying to say that we mostly use colons for emojis. We don't use them for many of the purposes for which they were intended. Another fun one, in today's day and age, this graph is, of course, saying there's several responses when you see an accident or witnessing a problem. Most of the time, people take videos. Most frequently, people take videos. It's a little bit less than most of the time. A second most frequent response is they stare like idiots. Many people do nothing, but rarely do people actually do something. I really like this graph because this graph explains how people feel about our good old state of Nevada, that everybody thinks it's nothing but Vegas. And it uses a pie graph, but it's artistic in that it doesn't choose a pie shape. It chooses the shape of the state of Nevada. You can do this kind of stuff with pie charts all the time. Choose a random shape and fill it in as appropriate. Okay, moving on to line graphs. Line graphs are super useful tools and probably the most frequent one in science. They're good for showing trends and relationships, and they have both X and Y axes. When we see a line graph in math, we typically see it with all four quadrants present, but usually in science we just focus on quadrant 1, with just the X and Y axis meeting at the origin in the bottom left. Values increase as you move away from the origin, like they would in any graph. Sometimes you'll see people mess with this, like in an HR diagram in astronomy, but usually values increase as you move away from the origin. And here's when you know you want a line graph. You want to use a line graph when you have number values or quantitative values on both of your axes. When you don't have any categories, it's time versus number of people, or it's temperature over distance, or whatever it is. Or whatever it is, there are number values on each axis, both going up as you move away from the origin. Okay, a couple funny line graphs for you. Of course, first of all, this isn't a line graph at all. Shows what a line graph looks like when you're spending time looking at it. a mountain range looking through a tennis racket. This is ability to draw mountains over time. So as you see at the beginning on the left there, they're not very good at drawing mountains and they get better and better going over. Again, these are humorous ideas. Here are some ones where we talk a little bit more about the actual values you might see. So appreciation for parents. This graph is saying that teenagers don't appreciate their parents as much as they did when they were kids and as much as they will when they're adults. Again, you see number values on the x-axis there, and on the y-axis, it's an implied number axis where it's higher at the top and lower at the bottom. Vehicle we expected to have when we're 33. This one is pretty good as a graph. It illustrates that your expectations get more and more realistic and then depressing as you get older. When you're a little kid, you expect to have a spaceship. As you get older, an F-16, Lamborghini, and by the time you actually buy a car, it's a minivan. This doesn't have numbers on the y-axis. So technically, this wouldn't be the best line graph there is. But that said, it certainly does have a clear relationship where the weakest or less appealing vehicles are at the bottom and the most appealing at the top. This is more of a scatter plot, but it still uses the same idea as a line graph. This talks about the relationship between effort and fun and pets. Something like a baby is a whole lot of work, but not terribly fun. Your friend's dog is a whole lot of fun and not a lot of work. Things like sea monkeys are not much fun, but also not much work. You just put them in salt water and let them go. Tropical fish or creatures like my axolotls are a lot of work, but not much fun. I disagree, but what can you do? Then you start talking about animals like horses. Horses take a lot of work, but they're a lot of fun. And of course, off the charts here are dragons. A lot of fun, a lot of work. They burn stuff. But again, this is still using the same kind of idea as a line graph, but this is probably technically referred to as a scatter plot because they're individual points and there's not a line going. Okay, bar graphs. First of all, bar graphs are often referred to as column graphs as well. If you're using Excel, Excel tends to use them if they're vertical bar graphs, it calls them column graphs, and if they're horizontal, it calls them bar. They're both types of bar graphs. It's just deciding what you put on the x-axis and what you put on the y. These are the types of graphs you use when you have values on one axis but categories on the other. So not two sets of numbers and not a very clear scale or sliding scale, but you have numbers on one axis and values on the other. So some examples, how long it takes to fall in love. So here we have time on our y-axis where it says in real life it takes about a year to fall in love. In movies, 3 weeks. In fairy tales, it happens almost instantly. It's just making a statement about fairy tales, but again, we're seeing on one axis, we're talking about how long it takes, the other one, categories. Similar idea here. You're correctly spelling when you're writing in Word or spelling in your head. Less so writing on paper, less so with a big presentation, and least of all when you're texting someone you like. And finally, Venn diagrams. So Venn diagrams are types of graphs that we use when we talk about qualitative relationships between groups. When we don't have any numbers, we're just trying to explain the relationship between two groups. These are more conceptual. We don't see them in science when you're trying to present data. But sometimes they're good when we're trying to understand how groups interact. So here are a few Venn diagrams. Again, the concept of a Venn diagram is you have different circles, and where they overlap, it's where they meet both criteria. So for example, in this one, the food I eat is the red circle. That's all of the food this person eats. So for me, it might be pizza and sushi and pasta and bagels and everything. The green circle is food that I know how to cook. I can cook pasta, I can cook pizza, can't cook sushi, can't make bagels. So some of those things I know how to cook. And then there's the food that I eat. Well, the food in the middle is what I cook at home every night, and so I'm kind of tired of eating those things because the pasta and pizza I know how to make, I'm tired of making. And so that's why that category in the middle is that overlap. It's things that I'm tired of eating. So again, Venn diagrams, showing both. This is kind of a joke about people who say they're fine. When people say they're fine while they're crying and doing all this kind of stuff, chances are they're not fine. When things are actually fine, they typically don't say it, but every once in a while, when someone says they're fine, they mean they're actually fine, but there's a very tiny overlap. This is a bit depressing, but this is saying there's no overlap between the things you have to do and the things you want to do, which is somewhat unfortunate, but kind of funny. And again, just being kind of funny, pandas are, of course, both black and white, so they meet the characteristic of both black bears and white bears, or polar bears. All right, so that's my introduction to graphs. Hope that's helpful to you. Let me know if you have any questions, and good luck on your work.